Hello students, welcome to Neural Networks. In this video we are going to understand how neural network works, how machine learning works, how machine learns things, and how machine identification works, and how artificial intelligence are made upon using these methods. So this is the basic structure of neural network, and now I'm gonna step by step explain this whole structure to you so that you can understand what is going here. So let's start with these circular or spherical cells. These cells are known as digital neuron cells. And what these neuron cells do, they just store the data, they just process the data and provide output. So obviously its three characteristic states that it can store some amount of data and then process it and then also can store its output. These wires like structure you see here are basically nodes, and what these nodes do, they just transfer data from one neuron cell to another neuron cell in the next layer. And what do I mean by the layer? Well, there are three layers in the neural network. The first layer is an input layer, because first we need to input some data so that we can process that data and take an output. So yeah, this is an input layer in which we put data, and for this video we're gonna take an input of 7. This is 7, but this is not written correctly. As you can see, this is written in an irregular way. Okay, so deformed structure of 7. This is not the correct structure of 7. The correct structure of 7 will be somewhere like this, or maybe this one. But this is not the exact structure, this is the deformed structure. We want our computer neural network to identify this structure as 7, because our neural network is trained to identify numbers structure, like which kind of structure does it match with which kind of natural numbers. This is the basic structure where three layers are given. The input layer, in which we are going to input datas. So we have this data, we are going to input into the input layer, and then input layer will divide the whole data into the all four digital neuron cells. And how will it happen? So basically, computer networks algorithm says that divide the picture or input into some parts. And as you can see, I have divided these into parts, into lows. So for this is the first low, this is the first low, this is the second one, this is the third one, and this is the fourth one. Divided this data into four different lows because we have four neuron cells. This computer instruction was given by the AI's algorithm, or whatever we have used to train our AI model. That algorithm said that divide your data, and every time your neural network is gonna divide your data into the amount of cell input cells they have. Why is it so? Because an input cell can store an amount of data between the value of 0 and 1. So here's an example that we have a 7. So we already know that we have divided the 7 into 4 different parts, and every part of this structure contains some amount of percentage of the whole structure. So let us assume that this first neuron cell, which is also named as a to the power 0 and 1, and the series continues with the name with the exponent 0, but the lower exponents is changing order to the serial numbers. So let us suppose this A1 cell consists of 0.5, and then the second cell contains an amount of data 0.38, and then the third one contains 0.6, and the last one contains 0.6 again. Now if you sum all these up, it will result as 1, because we already know that this whole data is 100%, and 0 is the 0%. Obviously the 0 means there is nothing, there is no existence of data. So If there was nothing, the every value of the cell was 0.00. But when we inputted the data, and data was divided into four different cells with some part of percentage. Okay, what I'm trying to say is that this will be some percentage of the whole part, whole structure. So that percentage is basically shown here. If the first part is stored in the first cell, then it is the amount of percentage that the first part contains from the whole structure of 7. And now same goes for different cells and different parts of scenarios. Now there is a question that why this neural network using only 4 different digital neuron cells. Basically this is because our information, which is basically an image of the formed structure of 7, is presented under the 2 by 2 grading pixels. And what this 2 by 2 grading means, let me explain it to you with a diagram, with a fresh new diagram. As you can see, now I have divided this whole square into 2 by 2. If you count from vertical stairs, you will find 2 pixels. If you count from horizontal stairs, you will find 2 pixels. So this is basically what I mean here by 2 by 2 pixels, and that's why this whole images is divided by the pixel, not by the computer algorithm. Just computer algorithm says that the divided pixels will be stored in the different amount of cells. So yes, the amount of cell depends upon your data, that in how many pixels the data is represented. So here our data was represented under only 2 by 2 grading pixels. So just it had to divide the data into its 4 different digital neuron cells. If you have a large number of data, clusters of data, then the neural network is going to take millions and billions of input neuron cells. So yeah, these things only depends upon your data, that how many pixels your data is using to represent itself. So now we have finally understand that how the data is inputted into the input cell. Basically there are more programmable systems and more complex algorithms running behind this neural network, but you don't need to understand them right now. Just understand the basic functions of neural network so that you can able to understand how AI learns. If you're gonna understand the algorithms, it will take a lot to understand it. So yeah, you can leave that topic right now. We will discuss that in another video. Okay, so what we have came across, let's recap it, and then we will move towards our hidden layer. We learned that there is an input which is to be putted into the input layer of the neural network. It will be divided into neuron cells on the basis of the pixels used by the input to represent itself. In our case, it was only 2 by 2 grid, so it divided whole data into 4 different neuron cells and stored some amount of percentage carried by the different parts of the whole structure. Actually, there will be 0.06 because if you sum all these up now, then it will result 1. So yeah, I just recorrected it. So basically we knew that our data was divided into 4 different pixels and 4 different neuron cells. But here you will say, or you will assume that your data was divided into 4 different edges. Yes, 4 different edges, because a part of data is considered as an edge. If you consider this chalk as your information, then the upper part will be the upper edge, the middle edge, and the lower edge. So yeah, that's basically why we call this part our edges. So in our hidden layer, there are edges stored, and how they are stored. So basically, when you train your computer system, you represent some pictures and you make them understand that okay, so this is a 7. This 7 looks like there is a bar, and there is an upper line, and there is a vertical line at 90 degrees, and then you assume that picture as 7. Sometimes your 7 have a intersection point between the legs of the 7 of this structure, and then computer learns that there are two parts: a bar, a vertical line, and a horizontal line, and a 90 degrees between them. So yes, That was our edge information which was stored during we have trained our neural network. Basically how your mind saves the information that okay, so how a dog looks like, whatever the pattern you have in your brain, that how a dog or cat looks like. So basically there are patterns to recognize the structures of numbers stored in the hidden layers. Now if you see, these all digital neuron input cells are connected with the single hidden layer cell. Why is it so? Because every data is needed to be compared with the data with the edge information of the first cell. So what is going to happen here? So let me explain you that we have every data which collectively forms this kind of a structure. This structure is going to overlap upon the data presented in here, which is a bar on the left side, and here is a bar on the left side. So you understand, both if both are connected together they form a bar, a full bar. So this data is going to be overlapped. So how is this going to overlap? So basically it is going to overlap by the using of pixels, and then computer algorithm will see that okay, so this is currently matching, this area of the data is matching with this area. So this hidden layer will approve the data collection and proceed it to the next hidden neuron cells for the data rematch approval. And since there are also all nodes connected with this single cell, so I have not shown in the figure because it will be a lot messier for you to understand, so that's why I've just connected one. But yeah, assume that every single node of each input layer is connected with this and this. Every hidden layer cells are connected with every digital neuron cells of input layers. Then this all data will be transferred here, and then the computer system will assume that okay, this is the left part, overlap the data. So this is overlapped, wait, this is overlapped. Okay, so this part matches. So yeah, data approved. There's not only data approving, how computer understands that data is approved and we need to move our data into the next hidden layer. So basically that concept is known as the lighting up the cell. Lit up, basically this is a process, or this is a phenomenon in neural network where a digital neuron cell lights up or glows to identify or to approve a matched pattern of the data. Basically, as we have studied that this pattern was matched with our data, so our hidden cell approved the data, and by approving it, it glows a little bit. It will glow like, it will glow, just understand, it will glow to make computers understand that yes, this data which was inputted was matched with my pattern. You can accelerate the data into another cells to match. So yeah, that was the basic concept of lighting up of cell, because they identify that how data is approved and just put it into another cell for the more verifications. If the data is not matched, it will not let up. So that indicates that yes, you can also send it to another for further verifications, but I don't approve the data matching. My edge information does not match with the provided input data. So we have came across that this was also matched, the second layer was also matched. Third layer consists of two legs, but they are divided by the space between them. So but we already know that our leg was also divided, so our picture will be overlapped. Basically our data will be overlapped, and they say that yes, the pattern matches, this one also glows, and send this whole network with an approval sign into the another digital neuron cells of hidden layers. Now there is an interesting part. Basically, there were small edge patterns, but now the patterns became and joint, which I have said earlier that they are meant to be joined and to take part in pattern recognition. So now the patterns are jointed and the data will be transformed from this neuron cell which is in the hidden layer, into the second cluster of hidden layer. Basic cluster is in layer like structure which is present in the single layer. Hidden layers may have two or three clusters, like group of layers in a single layer. So now in the second cluster we have large edge datas, edge informations. So there is a full bar which will be overlapped by our provided data. So it will say that yes, this matches, and this one also glows up. This one also glows up, and then it will send into the another digital neuron cell. And as you can see, our edge information have a part. So you can see, assume this part as an this edge information. Similar, they're similar. So this will also getting improved, and cell lights up, and then we are gonna accelerate our data into the another cell which represents the whole leg, and it will be overlapped by the data to match. But basically what's happening, we match the data by overlapping them, like by comparing side by side. So yeah, that's exactly what is happening here. Because they are pixels, so they are overlapped upon each other, so that the pixel coverage will state that how much data is matched with the edge information. This is also that yes, the data matches, and then it will also lit up. Now here comes the scenario of providing output. This neuron cell have finally identified these all things according to our provided input data. But how this network will know that which kind of structure it was? Basically, for this, the neural network will start a back propagation. This is a very complex concept in the neural network, but for now I'm gonna briefly explain it to you. So what basically this will do is that our data was accelerating now this way, from left to right. Now our data will accelerate from right to left, but not further, because are 8 and 7, there are only two outputs given that identify what the input was, 8 or what is it was 7. So now the computer network will understand the structures and match the structures with the identified input data. It matches with the structure. 8 will never match because it's have some two donut type structures, and this have a particular structure currently matching with the provided input data. So it will say that okay, let me lit up the cell, and this is the output, and it will provide the output as 7. This is how computer predicts that the data was identified as this. Whatever you say to your computer, it will first break down, and then it will process your information or your request as an output. Basically, this was the very basic mean of understanding the neural networks. There are a lot more for image generations, for vocal recognition. So for vocal recognition, there will be some kind of frequencies is stored in the hidden layer, so that they will create voices of AI. And if you talking about image generation, then there were so many clusters of data, and they are storing the mountains, like how mountains look like, how sun rays look like, how birds look like. So every understanding is saved inside the hidden layer, and then your input data is proceeded with the calculations, with the understanding, with the neural network, and then it will provide an output. There is more to talk upon this subject because this is not much easier, this is much more complex, but for now it's enough for you to understand the basics of working and learning of AI. In another videos, in another some upcoming lectures, we will understand the AI algorithms, quantum algorithms, and how AI algorithms are made, how they work, how they are programmed, what are tensor flows, what are packages, how you can program or make your own trained AI models. There are many things to talk upon, so we will discuss them on another topics. Till then, take care everybody and study well. Bye bye. Jai Hind.